Let's begin. Let's begin.
And during the past decade, we have been advocating for the adoption and development of We organize events related to open source. Bangkok, Thailand, Vietnam, Indonesia, India. We also have an open summit in China. And today we are very happy to co-organize this event together with ByteDance Open Source Program Office and Root Open Source Program Office and Dao Cloud. The event of today. So we put together a program for you that highlight a number of innovative open source solutions. I'm gonna name a few of them, and then the speakers that we have here today will go more into the details. So we have CloudWeGo. I don't know if anyone heard of CloudWeGo. This is an open source middleware set developed by ByteDance, and it helps to simplify the construction and management of enterprise level cloud native architectures. Another component of CloudWeGo that's going to be presented today, which is KaiTech. This is a high performance remote procedure core written in Golang, also developed by ByteDance. And we have another tool that's called LayAuto. This is an application runtime developed using Golang as well by Andrew. Another project of Andrew that's quite famous already, maybe some of you are aware of, which is Complex, a modular development framework to have transition to from traditional application to serverless environment at a minimal cost and effort. And finally, last but not least, if you were here the last meeting, you heard a lot about Dao Cloud and what they do in terms of open source. Today, we also have another project from Dao Cloud, which is Workbridge, a tool that is designed to optimize mesh performance using eBPF. Okay, so the agenda, you can see on the stage here, we have 6 presentations today. Every presentation will last about 15 to 20 minutes and followed by 5 minutes Q&A. We have prepared some presents here for you, sponsored by CloudWeGo. So for people who ask questions and share ideas or examples that they can use inside your company. Okay. This event is being streamed online, so we do take questions from online. So if you have any colleagues that cannot make it here today, it's streamed on YouTube, LinkedIn, and also X, Twitter before. You are free to take any a photo of the slide, whatever you want to record for your own memory. We also share the slide later on at the end of the meetup. What else I want to say? If you need to use the restroom, right outside on the right hand side. So there is one for men and further down for the women. Okay, so with that, I would like to introduce our first speaker. So I have here with me today Luo Guanling, the community manager and architect at Now We Go. He's going to talk about, of course, give us an overview, introduction of Now We Go. Comment, are you ready?
Okay, ready. Thank you. Thanks for home introduction. Thank you. Hello, everyone. Good evening, everyone. My name is Huaming Luo. I am one of the hosts of the Meetup, and also I'm glad that I will be the first speaker tonight. I hope everyone will enjoy this wonderful evening and also can benefit from the sharing and the discussion coming soon today. I came from ByteDance and also the community manager and also the architecture and maintainer of CloudWeGo community. My topic today is CloudWeGo introduction. Okay, let's come to the agenda today for my topics. First of all, I will tell you what is CloudWeGo. I think many people might be interested, might be curious. And secondly, I will sharing what problem does CloudWeGo solve. Last but not least, I will sharing some use cases. Okay, let's come to the first part. What is CloudWeGo? Well, here, as you can see from the slides, CloudWeGo is a set of microservices middleware developed by ByteDance to build enterprise class cloud-native microservices architecture. It's a very long sentence, but if you look closely, you will catch up some highlighted keywords. Firstly, it was developed and open sourced by ByteDance. When we look at the history, in 2018, we had about around 7,000 of online microservices. However, by 2021, the number had exceeded 50,000. In September of 2021, we decided to open source the microservices middlewares to help more developers. And secondly, it is an enterprise class microservices middleware solutions, which means that you can use it in your own company manually. And last but not least, CloudWeGo provides both Go and Rust solutions. So if you are a fan of Go or Rust, congratulations, it might be your cup of tea. Okay, after a brief introduction, let's take a look at what are the core features of CloudWeGo that CloudWeGo provides. Firstly, the keyword is high performance. We developed many underlying technologies to support high performance. And my colleague, Joey, will share more detail in the coming presentation. The second one is stronger extensibility. We not only provide many out-of-box features, but also provide a set of interfaces for customization. The third one is multi-protocol support, including HTTP, Swift, and gRPC. The first one is the built-in code generation tools. It provides users with usability and will save your time in coding. Besides, CloudWeGo is also cloud native and AI native, which I will introduce later. And most importantly, high availability. You should have no worry if you use CloudWeGo to build your core business logics, because ByteDance already used that in our internal system for many years. Okay, so far we know what is CloudWeGo and its core features. But what project that it truly provides? This picture will give you the answer. For the left side of the picture is our Go ecosystem. It provides Go RPC framework, Calyx, and Go HTTP framework codes. But below the framework layer, CloudWeGo provides many high-performance sub-projects in codec, network library and runtime, and many tools middlewares. For the right side, you can see it's our Rust ecosystem. We have Wallow. This framework provides Swift RPC, gRPC, and HTTP framework, and also many other Rust ecosystems. Next, let's take a look at the CloudWeGo community. We can't be successful without the help of the community members. Based on the latest statistics, CloudWeGo now has around 400 contributors in total. They are coming from different countries, covering different areas. Contributors here has a very clear growth path here. Every contribution values and will get reversed physically and spiritually. So you guys are also welcome to join the community. On the other side, CloudWeGo now has more than 170,000 individual visitors who have visited the CloudWeGo website for guidance, knowledges, tech blogs, and CloudWeGo related news. Those individual users are coming from China, Singapore, United States, Japan, Indonesia, and many other countries, including countries from Europe, Australia, and Africa, almost covering the whole world. Okay, so far, let's already sharing what is CloudWeGo, but what the problem does CloudWeGo solve? That's the second part I want to share. In microservices architecture, that is also the core topic today. Communication and governance between services are always very important issues. CloudWeGo provides a set of middleware solutions to focusing on solving the problems of communication and governance under microservices scenario. Firstly, in the scenario of RPC, Calyx, the Gona RPC framework, provides one-way ping-pong and bidirectional streaming for message type, which can be used in different cases and scenarios. To provide high availability, we provide many service governance capabilities, such as service discovery, load balance, circuit breaker, retry, timeout, fallbacks, and so on. Most of those features have been provided with default implementations, and users can also choose to integrate with flexibility with your own customization. In the second scenario, which is HTTP, the Gona HTTP framework provides out-of-box support for HTTP 1.1, HTTP 2, HTTP 3, and WebSockets protocol. In addition, due to its layout design, you will be very easy to do the custom implementation for the protocols to adapt to your own case. And to solve the problem in HTTP and web applications, Hertz provides many out-of-box middlewares listed below, including cross-origin resource sharing, JSON Web Token, pproofs, SDKs, Swagger, Sentry SDKs, and so on. The second capability that I want to address is code generation. Calyx and Hertz, as a framework by default, provides built-in code generation tool. For those who want to use Calyx and Hertz in one team or in one services, we want to unify the user experience. Under this background, we developed a tool called CWGo. And this tool will allow you to unify HTTP, RPC, DB, including MySQL and MongoDB, so that you can generate the codes at once. In the future, we will support more features. My colleague Guanyu Song, we are sharing more in detail about this tool. And the third capability that I want to highlight is cloud native that many people might be interested in today. CloudWeGo is very friendly to cloud native ecosystem. And you can easily run your microservices and to publish it in the clouds. The features including Kubernetes and container friendly. Suppose integration with Istio with multiple discovery service protocol. and suppose Prometheus and OpenTelemetry for metrics and tracing, suppose graceful shutdown solutions, and many other cloud-native features. If you take a look at the picture on the right side, you will find Calix integrates with many cloud-native technologies, including the projects from CNCF. The first and the last capability that I want to mention is CloudWeGo is also AI native. In the past 2 years, we all know that AI application grows at a very incredible speed, and so does embeddance. To support the AI scenarios, we develop CloudWeGo quickly developed high-performance RPC streaming through Swift. And we also supported the server-side events technologies with the help of the CloudWeGo community. The server-side events is also called in short SSE. It's a standard allowing server to push real-time updates to clients over a single long-lived HTTP connection. It is unidirectional, while only servers send data to the clients. SSE is simple to implement and efficient for text-based data, but it cannot handle bidirectional communication or binary data. While RPC streaming allows for bidirectional or unidirectional streaming of data between client and server over various protocols. They commonly used in HTTP2 over gRPC. It is suitable for more complex interaction, such as chats and data transmission, real-time data transmission. It supports binary data and bidirectional communication. However, RPC streaming is usually more difficult to implement, and you need to do more difficult, complex configuration. Okay, so far we have already shared some of the capabilities that CloudWeGo provides. Let's conclude and summarize. What do we need? Why do we need CloudWeGo? And what does CloudWeGo plays in the role in the microservices development process? Let's look at the pictures. Developers can use CloudWeGo to build its microservices. In this case, CloudWeGo provides its core features in the RPC and the microservices. And that is the core of the CloudWeGo. However, in the dev process, you need more, not only RPC. CloudWeGo provides tools to generate scaffold code, both client-side and server-side. That's one of the capabilities listed in the right side. And in the distributed system, CloudWeGo also provides service governance features for east-west traffic, provides observability for debugging and monitoring, provide registration and discovering for auto-scaling, provide config management for dynamic control, and also provide many middlewares for securities. After writing all your business codes, you can easily upload your mirror and run it in the cloud. Now, many public clouds by default support Calix in their Microsoft service-related cloud services, including Alibaba Cloud, Tencent Cloud, Huawei Cloud, and Volcano Engine. Okay, then we come to the last part. We were showing what are the use cases. CloudWeGo can be used to build a variety of other applications, such as web application, backend platform application, and also internal system applications. Industry adoptions including many areas like gaming, security, e-commerce, and specifically AI. As you can see from the slides on the right side, all the business from ByteDance uses CloudWeGo to build its own applications, including Douyin, which is the Chinese version of TikTok, and Jianying, which is also the Chinese version of CapCut that you might already installed in your cell phone. We have also many other users outside of ByteDance. The first group are the users who are using Go by default. We have some successful use cases. They are coming from Huaxin Securities, Sima Inc., and Shumei Technologies. The first one, Huaxin, listed here. They use this Calyx and to make their new apps at the very beginning. And we have Sima Technologies. They use this Calyx. Or compared with gRPC, the Think Calyx has better performance. And they successfully integrate Calyx with Istio to build its microservices governance system. And we also have the Shumei Technologies. They originally used Apache Swift, and then they shift to Calyx Swift for service governance features, and more specifically, the high availability provided by Calyx. The second group are the enterprise users. They shift from the other languages to Go. Well, this is more interesting. Firstly, let's take a look at the Taiwan game company. They originally used PHP to build their internal SDK systems, and then they choose to switch to Go using Calyx and Hertz to build the new microservices. The second company listed here is Thunder Securities. They originally used in Java, and is specifically using Double as a framework. And then they shift to Go using Calyx to build its new microservices system. And in the end, they found again a lot of availability and performance. The last one is the Construct. They originally used in Python, and now all the new applications are shifting to Go, using Calyx to make their new microservices architectures. And they successfully integrated with Istio for service governance. And they published all the applications in Alibaba Cloud. Okay, so far I have introduced what is CloudWeGo, what problem does it solve, and what are the use cases. If you want to know more, please visit CloudWeGo website, CloudWeGo GitHub, and also please follow us in Twitter. If you want to get in touch with us, welcome to join the Discord channel that is listed at the middle. You can scan the QR code to join our channel if you haven't yet. And if you are speaking Chinese, you may also join our official chat group and follow us WeChat public accounts. And that's all. Thank you. Thank you for your listening. And I hope you can, yeah. If you have any questions, that you may ask it now.
Thank you, Quang Minh, for the insightful presentation.
Thank you.
Yes, I mentioned before we have some present here for people who have interesting questions. Any questions?
Just a quick one. It's
Okay.
interesting to know that CloudWeGo uses for Rust and Go.
Yeah.
Interesting into know if there are plans to support other languages or other technologies in the future.
We do not have plans for other languages. Yeah, right now but we have plans for the framework in AI agent scenario. But the main languages covering Go and Rust. Okay, thank you for your question.
How well is the documentation for this and how much is beginner friendly?
Sorry, maybe you can hand over the microphone.
Yeah,
Okay,
this
this. Okay.
I just want to know about the how you are going to manage the security.
Security.
Yeah, I mean, like,
Uh-huh.
do you have any code standards, any warning standards, how are you?
Well, okay, I see. In the web applications, we provide many middlewares, like the JSON web tokens, and we have also the cross origin resource sharing stuff, and we will guarantee the communications through the TIS. What is the? It is a short name for to secure your communication. Well, those are also both supported in our HTTP framework. And if you're using RPC framework, you may switch to the standard network library, and you will be able to support the TLS protocol. Okay. Well, we have the last question. Just to time, maybe this guy. Okay, this one.
Yeah, I wanted to know about what is the documentation for this for developers and users, and how much it's beginner friendly.
How much is English speaking?
Beginner friendly.
Make it friendly.
Beginner friendly.
Friend.
New people can.
New beginner. Okay, I see. Yeah, for the documentation, if you visit the Calavigo website, you can go to each the project page. There is a separate page called Getting Started. In the Getting Started page, the newbies can learn from how to build an HTTP application and RPC application from scratch. And now we also make some new videos for the new beginners, and this will be published soon, maybe later this year. But firstly, I think you can first go to the website and check the Getting Started doc, and you will be able to quickly set up an application based on our frameworks. Okay, thank you for your question. Thank you, everyone. Okay, we can communicate later. There are more questions. Thank you. Okay.
So, thank you very much. So I have copied up next. Make remote the feature called faster than fast with a technology called KaiText. And I would like to invite Hu Wei, the maintainer of KaiText, and Network and Calavigo.
Okay, thank you, Tang. Hello. It's okay. Okay. Good evening, everyone. I'm Joey Wang from Cloudwago organization, and I'm excited to share you the performance optimization journey of KaiText. And of course, I'm the maintainer of the two projects. One is the KaiText, and another one is the NetPol. Okay, because since the topic of tonight is the microservice. So firstly, I want to discuss about the cost of microservice. Secondly, I will share some cases that how KaiText minimize the CPU and the latency cost. And then we will see some benchmark result between KaiText and the other RPC framework. So for the first part is the cost of microservice. Before we talk about the microservice, let's just go back to the age of monolithic architecture. At that time, as you see in the picture, we organize the different modules in a huge monorepo, right? And the different modules will communicate with each other by function call. And the cost of function call is very simple. It's just maybe 10 nanoseconds because it's just a pure function call. But there have some significant maintainability and stability costs because first, multiple teams will develop in same code base, and if you do that, maybe you will find that it's very hard to develop right. And another thing is if one module crash, and the whole service process will be crashed too. So that's why we have moved to the microservice architecture, which has become the most popular architecture today, and that's why we're here. At this time, you will say that different services communicate with each other by RPC calls. Sorry. Okay. By RPC calls, right? And of course, the RPC calls will transmitted by network. And every service have the maintainability and the stability. Because the different team are responsible for the different service, and no need to care about other service. And if one RPC fail, and it can try to call another one. So there are more stability. But the RPC call cost is very huge. It's maybe up to 1 to 100 milliseconds. So let's say what constitute the cost of RPC. As shown in the left picture, you will see it is a very typical RPC service. The RPC service, because you need to read a request in, and you process the request, do some business logic, right? And then you need to write the response back. So let's begin from the bottom. The Linux kernel will read the real data from network, and then the framework will read the data into a read buffer, and then will decode to a request object. And then the response will be encoded to a write buffer, and then over network. So we can see there are two parts of cost. One is the CPU cost. It's included the codec, which is encode or decode, right? And another is the IO system cost, which is also very huge in the online system. And another thing is the latency cost. One is the kernel thread scheduling, and another is the network transmission. So we can say that's the challenge to move to the microservice architecture. But we need to fix it. So we create CatX. CatX is a high performance and strong extensibility Golang RPC framework, and helps the developer to build a microservice. If you are developing microservice in Golang and are concerned about the performance, maybe CatX will be a great choice for you. So let's move to the part 2. We reducing the CPU cost by optimize our CatX codec. Before that, let's talk about what is codec and why we need it. As shown in the picture, let's start from the bottom 2. One buffer needs to, when that data come from the network, the socket the data will come from the kernel space buffer, and then will copy to a user space buffer, and then mostly is the framework will decode and decode the data from user space buffer into a request. So we can say that codec is just a help to translate the data view between human view and machine view. Human view is for the developer, and the machine view is for the network or Linux kernel or CPU, right? And the codec is very highly CPU intensive. With our online machine, it consumes over 20% CPU usage just for the codec. So that sounds very horrible, right? So that's the challenge we meet. So the first optimization is to optimize the codec. The first thing is no copy rate. The left picture shows a typical way to read our data from user space buffer. You can see there are two memory. One is the user space buffer, and another one is the new string. Because for example, we now have a request here, and the second field is the string. So we need to create a string first, and then we need to copy the data from user space buffer to the hello to the new string. So there is one copy, right? But we may have many fields, so there are lots of copy in our system, and the memory copy is a killer for the CPU. CPU don't like the copy work because it's consume too many CPU. That's why we do the no copy rate, which shows in right picture. You will see the request field 2 just use the user space buffer memory directly without any malloc. And another is no copy write. It's very similar with the no copy read. The user space buffer will use the memory of request to directly and will not create any malloc. That's the no copy read and write maybe will seem very simple, but it's not easy. Because for that, not every buffer structure can support no copy read and write. If you write some code for that maybe you will understand. So we design a new buffer structure, which called the link buffer. The link buffer is composed of multi-single buffer node. As shown in the picture, for example, we have a response structure and it has many string fields, like field 1, 2, 3. And in this case, every field will be wrapped as a single buffer node without any copy, because it's just a node. And the link buffer is just work as a linked list. So, and then with the help of write-v system call, which is provided by Linux, it could allow us to write multiple buffer node with a single system call. So there is no copy work, and there's no copy work, and there is only one system call. That's the key to the no copy read and write. Another optimization is reduce the object malloc, because we are using Golang, but and Golang is a language with GC. So the garbage collector, for the garbage collector, less object malloc means less GC work, and of course less CPU usage. The fields like map or list will contain multiple points. There are two ways to create multiple objects in Golang. The code A shows a typical way. Maybe you are right, Golang is maybe the normal way you create a multiple object. Here, we will, in code A, we will call malloc n times, and then we will create n points. And the code style B, it just create one big point and only call one malloc once. But why code B is better? Because first, GC only needed to scan the bigger point once, because we only just have one bigger object. And next, the contiguous memory address will make the CPU cache happy, because there is only one object, so the memory, of course, it is contiguous. Oh, so let's move to the third part. I will show you how to reduce the latency cost by optimize CatX network layer. Before we talk about the optimization, let's say what's the issue of GoNet library. As shown in the left picture, for the design of Golang runtime, it will, if of course RPC server will accept many connection, right? And for Golang, every connection will create a coroutine for it. So it will lead to a very high coroutine scheduling latency. And the native read and write API in Golang does not support no copy read and no copy write ability. So, what happened? Okay, so that's why we create a new project called NetPo. It's an alternative to GoNet library. NetPo have two advantages. One is the high throughput. We can see in the left picture, there are connection here. You will see that it only stores the connection FD in memory and without any coroutine. And if a connection has some IO event like read and write things, it will start a coroutine to do that. So it helps us to create a million connections without any coroutine. And it also supports the no copy codec. And another advantage is the low latency. Because it's independent from the Go runtime scheduler, it has its own epoch loop. So it will have lower latency than Golang. And it write data within the same Go routine, so it could enhance the cache efficiency. So after saying so much, let's say some benchmark between KiteX and other RPC framework. We picked up some well-known Golang RPC framework here, and the most famous one is gRPC, which is the gRPC Go in GitHub. Yeah, both in throughput and latency part, KiteX is always the best performance framework, and the data source link is at the end if you have interest. Because today we just have 20 minutes, so I just show a little work KiteX did in past few years. But we also create many other projects on the Cloudways Go family. Cloudways Go is a big family to gather all efforts we did in microservice field. For the server framework, we could use KiteX for Swift and gRPC protocol. And we have hosts for HTTP protocol. And for the serialization, we have Sonic for JSON. I think everyone uses JSON, right? And we have FastPB. If you hear about it, it's protobuf is a protocol come from Google, but now it's very popular. And we have FastPB for protocol serialization. And we also have the Frugal for the Swift. For the I/O layer, we have the NetPo mentioned before for the network. And we have ShameRPC Go, which is the shared memory IPC communication library. And that's just a little of our project. We have more projects, but if you have more interest, you could find the GitHub, go to GitHub, find more information. Okay, that's my sharing today. Thank you, everyone.
So listen here, we have
Okay.
time for one question.
Okay, so for the last slide around the serialization layer,
Yeah.
I wonder what is how we go to follow this system framework gRPC. Because I think those framework already do the serialization of the encoding and decoding. I'm wondering what's the additional things that how you go.
You mean what we do in gRPC protocol, right?
Yeah, the serialization layer.
Yeah, because gRPC use the protocol gRPC use the protobuf, right? So that's why we create a FastPB, because we support gRPC protocol, and the serialization protocol is the protobuf. So we create a FastPB, and yes, there are some optimizations for the FastPB, but it's very very hard code, and it's too much detail. But most of it is the same. So the logic is same to reduce the object on malloc, and then do not use the reflect, because if you use Golang protobuf, you will know there are too many small object malloc, and there are too many function calls for the protobuf codec. So we need to reduce function call, reduce the object malloc. That's how we do it. But the further detail is maybe the code will tell you more detail. Yeah.
Thank you.
Thank you.
Thank you very much. Actually, we are running a little bit tight on time, but Drew, we're going to be here until the end of the day. You can question later.
Yeah, we can discuss it later. Yeah.
Okay, thank you. So up next, so we have a presentation about improving development efficiency, and I would like to invite our next speaker, Fan Quang Yu. So he is the maintainer of CAP and CW Go at Cloud.
Okay. Hello, hello everyone. My name is Guangyu Fan, and I'm infrastructure engineer at ByteDance. It's my pleasure to be here today to share my insights on key to efficiency that we insight into scaffold code generation for CWGO to enhance development efficiency. With that said, let's go started. In this sharing, I will cover the three sections. The first is overview, that I will introduce the challenge and the solution for the Clovico project performance development. And the second is that the key content for the sharing. I will introduce the CWGO tool for enhancing the efficiency for the Clovico project. And the third is the feature planning. My goal is to provide you the my goal is to provide you with the practical knowledge and the best practice that you that can help you to apply to your own project or workflow. Okay, this is the first section. Clovico provides two microservice frameworks for the Golang. For the Hertz is a Golang HTTP framework with high performance and extensibility. For the Katax, it's a RPC framework with high performance and supporting multi-message protocol. The Clovico project has the same developer flow. The first is installing the scaffold tool that used to generate a framework scaffold. After this, we will write IDL for the protobuf or Swift that used to prescribe the interface specification. After that, we can generate a framework-based code based on the IDL and the scaffold tool. And finally, we will complete our business code and deploy and launch the service in our produce or test environment. For install tool, currently Clovico provides all needs the following tools for quick development. HJ and Katax is the scaffold tool for Hertz and the Katax framework. And the validator is a request parameter validating tool for Hertz and Katax. And the compiler contains the Swift.go and the Proto-C that used to pass the Swift or Proto file. Although we provide much of tools to facilitate the quick development, there are still many challenges to be faced. The first is multiple tools. The first is multiple tools that cause many learning costs. For example, we need to install more than 5 tools before we starting development. Furthermore, HJ and Katax have difference in usage and ideal specification that further increase the cost of use. In addition to this, the project layout template generated by the currently scaffold tool is more basic. Users usually need to add a lot of commonly used components to realize their goal. Finally, the current tool lacks of CURD code generation, which is a very useful feature for the user. To address the above challenge, we have provided the solution CWGO. It's a short for Clovico all-in-one. It addresses the above challenge in the following 4 ways. The first CWGO unifies and integrates HJ, Katax, database, and other related tools to provide an all-in-one SaaS way. The second, CWGO abstracts and unifies HJ, Katax, generating capability and only keep the simplest and the easiest feature. The second, CWGO provides richer and more complete default code layout to help user complete the utilization of various features in advance. The last CWGO extends the feature to provide hacks, database code generation, and other related capabilities. Next is the second section. This section describes the full features of CWGO and how to use it. The first is installation and usage. We can install CWGO tool by the go install command. CWGO mainly has server and client subcommand. For the server, it can generate Hertz or Katact code based on IDL for HTTP or RPC service. For the client, it is used to generate Hertz or Katact client code for calling the target service. Here I provide a video to show how to the basic use of CWGO. Firstly, we can write our service IDL. This IDL defines one service with one method. Naturally, we can use the CWGO server and the client command to generation the server and the client code. Like it's so the default layout for the CWGO. And naturally, it will show how to create a Hertz service by CWGO. It's similar to the RPC. Based on the above demo, I will first introduce the overview of the code layout generated by the CWGO. The default code layout for CWGO is MVC structure. It can help user developing quickly, and we add a BJ-dev director for helping user utilize the database connection and other database operations. And we add a unit test file and utilize the test code to reduce the workload for user to write a test. And furthermore, we also add the necessary common logic for the handler to help user to quick complete the business code. The HTTP code layout is similar to the RPC layout. This is because we want to help user sell as much of the details of the framework as possible. Furthermore, the HTTP layout only adds extra BJ router directory for the HTTP route. In addition, CWGO also offers the ability to customize the template to help users achieve their highly customized code generation. It has the following features. The first is that you can modify all the default generated code if you wanted to do that. The second is that you can add your own customized template and get all past the IDL information to generate code. The last is that all the template is defined by Go template syntax, and the CWGO adds a lot of useful template functions. You can see the template extension link for more usage details. To facilitate template management and enable template usage in collaborative scenarios, we have provided two template management ways. The first way is local storage. You can store the template file in your project and generate code with it. And the second way is remote storage. You can store the template file in the Git repository and use it by Git HTTPS or Git SSH. It also supports branch feature to help you better test and use the template. Naturally, I will introduce an interesting feature called CWGO hacks. Currently, if you want to listen both HTTP and RPC requests within a single process, we would either have to listen on different ports with the same process or use a gateway in front of the process to performance protocol conversion. However, with the HEX, we can quickly process both HTTP and RPC requests on the same port. HEX is a sort for Hertz and KTX, meaning that it integrates the Hertz and KTX frameworks at the same time to provide a unified form for CloudWago microservice. As shown in the picture, when the request enters the business process, the HEX will do protocol sniffing in the transporter and passing the HTTP or RPC request to the Hertz or KTX for processing. The implementation is that both Hertz and KTX use the same networking library network and have the ability to optimize the transporter to enable more interesting features. The HEX can the development infancy. In addition, CWGO has added the database code generation. The thirdly is CWGO MyCycle. CWGO integrates the GROM gene to generate CURD code by default. User only need to add the database type, and the DSN can quickly generate the CURD ORM code. Furthermore, MongoDB is also a NoSQL database that we can often use in development. We have observed that users often encounter some problems with using Mongo. The first is Mongo is more troublesome to use in some scenarios, reducing the development efficiency. And the second is Mongo doesn't support translations, block operation, and other operations. The last is there may be incompatibility between different versions of Mongo that may prevent users from using advanced features. As a result, CWGO developed the CURD code generation for Mongo, which solved the above problems. Now, let me introduce how to use this feature. Firstly, it's structured in Swift map a Mongo collection, and each field maps element in the collection. Then we can use Bunsen tag to mark the mapping of the fields. And lastly, we can use the Mongo point function to specify the CURD function to be generated. This function rule can be found in our document. With that done, we can use the CWGO doc to generate the CURD code. The graph shows the structure as well as the specifics of what it generated. The content of user repo and the user repo Mongo are the ideal defined Mongo CURD code, and is called corresponding implementations. The above describes what CWGO has done for developing infancies. We will continue to do it in the future as well. The first is IDL to Swagger. Swagger is a very common open API description tool, which is similar to the IDL. Therefore, we are working on the interconversion of Swagger and IDL to help users better manage their interface. And the second is generate a row circle based on IDL. Using ORM could reduce the could reduce performance for the service and may cause the online problem for our service. So we will also develop an ability to generate the row circle based on IDR. Lastly, we plan to develop IDE plugins to support users in developing Cloudways Go projects. For example, we will developing a VS Code or Golang plugin to generate a Cloudways Go service with one click, or we can supporting generate a code job, MQ, customer code, and so on. Okay. If you are interested in CWGO or Cloudways Go, you can access this link. Okay. Thank you everyone. Thanks for your time and attention. 有没有帮我翻译一下？
Does Cloudways Go offer anything like HashiCorp Vault for secret expressions? HashiCorp Vault.
可以帮我翻译一下吗？可以帮我翻译一下吗？
Please repeat
So HashiCorp Vault is
HashiCorp.
the vault.
The vault.
Something that's used to store secrets,
Yeah.
microservices. Does Cloudways Go offer anything or as well?
Not yet. We haven't integrated.
Any other question?
The things you have mentioned, VS Code, so it will be like fee, right? There won't be any charges if we go with the installation of the plugins.
You're talking about the VS Code 2 will be supported soon. Yeah, it will be free. It will be available for everyone to use. You can join our Discord channel and we will know that channel you can just.
Okay. And it will be available on some other ID as well, or only on VS?
We want to support the VS Code and Golang as usual. And yeah, if you have any other requirements or you can so you can provide advice to us.
No, not at all.
Okay, thank you.
Any other question on this topic?
Thank you. I have a question. Do you think that that kind of co-pilot tool in the future that makes sense? In addition for code generation, scaffolding, like GitHub Copilot?
Yeah, you actually raised a very good question. In the future, we have some plans to generate code based on the large language models, right?
Yes.
You can explain more in detail if. Well, internally, we have investigated in the large language models application stuff, and we will be used in the code generation later, but not right now. Maybe a year later. Well, thanks for your attention. You may just keep in contact with us. Thank you.
Yeah, so I just want to say that Guan Yu actually flew over all the way from Beijing and he came in today a little bit nervous. So thank you very much for your presentation. Yeah, and thank you, Pami, for having
Okay, thank you. Break.
So we will continue with the next presentation. So yes, so from the update, so we got something about practical implementation with multi-runtime architecture, and I have here today technology expert from Andrew. He also the project management committee of Lei Auto, an open source solution. Wang Wensui. Okay, are you ready?
Yes, I'm ready. Hello, everyone. I'm delighted to have the opportunity to share. This sharing is the practical implementation of multi-runtime architecture. And before we begin, I want to know how many people have heard the multi-runtime architecture. Okay, and he is my friend. And how many people have heard the Dapper project? Okay, so good. Okay, before we started, I want to introduce the origin of the name Leato to everyone. And we all know the OSI divided the network into 7 layers, and Leato tried to define a set of standard APIs to share the difference of infrastructure. So it can be considered as the 8th layer, and 8 is auto in Italian. So this is why it's called Leato. And many people told me the name is hard to pronounce, so we can call it layer 8 or L8. Okay, let's begin our sharing. Okay, before we begin, let's take a look at the traditional application development model and the issues associated with it. In the traditional application development model, when we build an application, we need to know the details of the infrastructure. Okay, and we need to know the infrastructure details and confirm the middleware that will be used. Then I can use the corresponding SDK. For example, if we use the RocketMQ for pub and sub message, I need to introduce the RocketMQ SDK in my programming language. And similarly, if I use the Narcos as the configuration management, I need to introduce the Narcos SDK. So the model is the most common way, but it brings serious problems. First, it's not feasible to offer SDKs for every programming language. I remember that I have one. The first question for Guangming is the cloud. We go have the good ecosystem, but for other programming language, what we can do, right? So the second problem is upgrade the SDK is challenging. And the third is the application is tightly coupled with the infrastructure. And the most serious problem in our group is we all know they have many complex logic in the middleware SDK, and Guangming have showed that in the Cloud Go community, they provide many complex logic for SDK. And currently in the open source community, the development and the maintenance of the SDKs is handled by the open source contributors, but internally within a company it's not feasible for the middleware team to provide all programming languages SDK. And for the second problem, upgrading the SDK is challenging, and we all know the application developers also don't want to upgrade the SDK unless they meet issues or new features required. So when I develop an application which will deployed on the infrastructure A, I can develop it directly based on the details of the infrastructure A. But one day, if my application need to deploy it on the infrastructure B, what should I do then? Maybe simple way is to create two branches. Then the first one is infrastructure A, and the second is infrastructure B. But it's difficult for the later development and maintenance. And as a business developer, I should not have to care about these things, right? I just want to pub or sub a message. I don't care if the infrastructure use the RocketMQ or Kafka. So I will introduce how to solve these problems in the group. First, I want to talk to you about the use of the service mesh technology in on group. About 2019, the on group completed the service mesh transformation of RPC and moved RPC complex logic from the traditional SDK into the sidecar. And most, for example, the service routing, the load balancing, and the traffic governance, as Guangming have said. And mostly is a cloud native network proxy. Writing in Golang language is open sourced by on group. And until now, there have about 4,000 applications have completed the transformation of service mesh. And we have a SRE team can upgrade all the applications sidecar every 1 to 2 months. After this, the RPC language, the RPC SDK is simple. So after complete the transformation of the RPC service mesh, we have been thinking, can we further advance the service mesh solution? And if we can move all the complex logics of all middleware from the SDK into sidecar. And in recent years, middleware team have completed the transformation of almost middlewares. As shown in the figure, the RPC, the cache, the MQ, the configure, all the complex logic have moved from the traditional SDK into the sidecar. So this makes the SDK very, very simple. And let's think about it. The service mesh solved the problem. Upgrading the SDK is challenging because we have moved all the complex logic from the traditional SDK into the sidecar, and we can upgrade the sidecar without user noticing to fix bugs or add new features. But there still have 2 problems left. This is just because every middleware has their private protocol, right? Have the private protocol. For example, the Kafka and the RocketMQ use the different protocol. So every SDK, every programming language SDK should implement them. Now I will introduce how we solve this layer 8. For the application portability problem, we all know any problem in computer science can be solved with another level of indirection, although they have another word. So we divided the middleware into the following types according to their capabilities. For example, the state is write for result data and QE value model, and the pub/sub interface is the publish and the subscribe message through various message quick, and the service invoke call service through most and other SQL data plane. And we defined a set of standard interface for each type. So this means the application developer don't need to use the SDK interface directly with the specific middleware. For example, the PubSub. In the traditional application development, I need to introduce Narcos SDK, but no, I don't care. I can program to the abstract interface. And if I want to change the implementation from the Narcos to ZK, I just can change the configure file, right? I can change the configure file, and the new SDK can adapt automatically to the different implementation. Oh, this is good, but it's required every programming language implemented. So, type the interface, and we have Motion sidecar. So, if we can make Motion support the abstract interface, this is the letter, and the open source letter 2021. To simplify usage for developers, we defined the interface with protobuf and employ the gRPC as the communication protocol. The protobuf and the gRPC is well established within open source community and offers the comprehensive support for various programming language, right? So any language can use gRPC with protobuf. And as the application developers, I just need to obtain the protobuf file and use the protocol tools to generate the corresponding code. And then I can access the middleware capabilities with gRPC directly. Don't need to develop any SDKs for any programming language. And if your application needs to deploy on different infrastructure, we can change the configure file through the path, and that can adapt automatically to the different components based on your configuration. Yes, so by the way, we can find the level developer based on the Motion. So they are one process. This means when you deploy Letter, for the Motion service mesh user, when you deploy Letter, you will have the capability to boost Letter and the Motion. You don't need to introduce the extra sidecar. We all know the sidecar maintenance is difficult for company. So we can use one. And next, and in the practice use, we also find there also have been a conflict between the portability and the practicality. This is, and if there have certain capabilities in component A and B doesn't, the interface definition will exclude that capabilities. So this means the application developers are limited to only can use the intersecting component, and this approach can ensure the application portability. However, we soon discovered that such an interface can't meet the needs of developers. Not all applications need the portability, but they need the comprehensive middleware capabilities. The capabilities that I can use through the traditional SDK, the new interface should be supported, right? So Letter adopts the maximal viable approach. Different with the minimal viable approach, the interface definition under maximal viable approach is the union of all components. The application developer can use the a unique capabilities to component A or component B. But when you deploy it from the infrastructure A to infrastructure B, that will retain a standard error. The component B not supported the capabilities. And at the same time, many common capabilities within on the group are not suitable for open source, but are there for integration into layer code. So for meet these needs, we provide customer extensibility capabilities. To provide the API interface definition with greater flexibility, the Lato framework supports a user-defined plugin mechanism, allowing users to easily inject their hook function capabilities. Many teams within our group have utilized this mechanism to move their common capabilities into the Lato sidecar to support multi-language development. Okay, finally, let's make a summary. Service mesh moves the complex logic in SDKs to sidecar, making it easier to upgrade the SDK. And let's define the status of standard APIs with Protobuf and use the gRPC as the communication protocol to allow users access middleware capabilities with gRPC directly. And Lato can adapt automatically based on your configuration to solve the application portability problem. And until now, there have about 1,000 applications within the group are using Lato, covering a rich set of middleware capabilities such as RPC, state, secret, PubSub, OSS configure, and some common capabilities within the group. And Lato solves the following problems. As a standard access solution for non-Java language, different programming languages can use the middleware capabilities. And the microservice startup acceleration and fast code start acceleration. Because as a sidecar, we can do the initialization before the fast start, before the function start. And no need to push user to upgrade SDK. User noticing. And generally, business capabilities migrate to the sidecar. It's not suitable for open source, but it's suitable for integrating Lato. And about the maintenance, the SDI team upgrade the sidecar every 1 to 2 months for all the applications. And Lato release new version every month. So this is all of my introduction sharing. And if you have other questions, you can contact us. The Discord channel is a new channel. I just posted this for this meeting. I think the GitHub is better. Thank you.
How does this relate to multi-runtime? Can you define multi-runtime?
This is a good question. Multi-runtime is I forgot to put the picture, but I can describe it. The multi-runtime is mean okay. Wait a moment. Here. The multi-runtime architecture means for one application, divided into 5 components. The first is the network, right? The network is still Envoy and the path, the Kubernetes and the runtime is layer 2. This means for an application developer, he just need to focus on the business logic, right? I have said we don't. If I want to pub or sub a message, I don't need to care about the details of the infrastructure. I just focus on my business logic. So this is the multi-architecture, multi-runtime architecture.
I see, so it's more like a multi-layer.
No. The microservice is a high level. Microservice is a high level, and we can move more capabilities from the SDK into the sidecar. I forgot to put the figure. I'm sorry.
I'm just a little bit confused about the multi-runtime. It seems multi-layer or something else. Yeah, it's okay.
Yeah. I know.
Yeah.
Hi. Regarding your quote about the additional layer of interaction to solve a lot. So one of the big issues with interaction is cost. So I'm just wondering, I think this additional layer about the runtime, how much latency does it cost? Because earlier we saw a presentation where where they try to improve the RPC performance, particularly on latency when you use zero copy units. So here kind of runs counters that yet another layer. Just wondering what the trade-off here is, cost.
Okay. If I said in official, I know the move the capabilities from the SDK into the sidecar will add the latency. Yes. About 2 milliseconds. Yes, 2 milliseconds. But as the Guangming said, the performance is bad. If the package is big, the latency will increase about 6 milliseconds. Yes. But in the component, the first step is all the programming language can use it, and the second can use it better. So the performance is until now we don't need to care about. Yes.
Thank you.
Thank you very much. Any other question? We actually have time for one more only. So I would give it to the lady. So we. What's the difference between Docker?
This is a good question. Difference. Yes, it's the biggest difference with Docker is I think is the interface definition, and Docker adopts the minimal variable approach when defining the interface. It just ensure the application portability. And it means if you deploy an application based on the Docker interface, it can ensure your application can deploy on any infrastructure with Docker. But Aleato adopt the maximal variable approach. They allow user to use all the capabilities of different middleware. And the second difference is the Aleato provide the customer extensibility capabilities, allow user to support their own API.
Okay, and thank you very much. I think this is all the time we have. Once you're gonna be around, right? So if you have any question, you can approach him at the end. We will share all the slides on the Meetup group later, so you can go also the content. Okay, so the next presentation we have the only female speaker today, also all the way from China. Li Peng. She is the technology expert also at Andrew, and the project management committee of Progress in Gosford Progress.
Thank you very much. Hi everyone. Are you also exploring the next job of microservices? I'm Liang Lipeng, a software engineer at Ant Group, and also a PMC at Catalyst. At Ant Group, we've tackled several major challenges in microservices and exploring the next job. Catalyst, a modular research and development framework and a serving platform. Today, I want to share our exploring journey with Maria. It's a little late. Let's play a game first. Have you ever developed a large application that takes several minutes to start up? Could you wave to me? Nobody? Really? Okay. And when developing business code, are you also tired of tackling the issues from making, deploying Docker images or connecting the database? Are you also dreaming someday you can only need to focus on business logic rather than the complex infrastructure? Slow start in the complex infrastructure or drag down our efficiency. And have you ever working with many developers on large applications? Have you ever encountered the conflicts when you are debugging, testing, or releasing? It's a typical scenario when your business want to split the large application into many small applications. Okay. Do you have many low traffic applications? Are you also considering how to reduce the resource cost? They really spend a lot of money. And it's another typical scenario when your business shrinks. Your business always changes rapidly, sometimes growing fast and also contracting fast. But the architecture is hard to evolve. It can change rapidly to meet business needs at a different time. So how to solve these challenges? To solve the low efficiency and the collaboration conflicts, the higher resource costs, and the less agile architecture. Later, I will talk about the road to solution, how we overcome these challenges. Then I will introduce the secret tools we provide, like our framework and the same platform. Finally, I will touch on our future direction. So how do we overcome these three challenges? We employ the modularization. So what is a module? Think of module as a simple standard Spring Boot application. So you don't need to change your programming practices. Especially, module is an application without the underlying infrastructure. By sharing the infrastructure, and the development, deployment, and start can be much faster. And we also apply module at the granularity level of development and operations, rather than the entire application, as solving the collaboration issues. And we also deploy many low traffic modules on one base to reduce the resource cost. Then we provide the tools to involve the traditional application architecture to modules like monoliths or microservices. Couplers can make your application fast as you need, pay as you need, deploy as you need, and evolve as you need. Let me tell in details. It's a traditional application. To share the infrastructure, we cut out the part below the business layer as a base application, which only contains the common business logic and the middleware. Business layer is also the module layer. For the business developers, also the module developers, you just need to focus on business logic, making it easier to understand and develop the project. And your module can start much faster, only taking a few seconds. For the base developers, common logic and middleware management are centralized, so you can upgrade the version more smoothly. The benefits are significant. For traditional applications, it takes more than 200 seconds to build and produces 1 GB imaging, whereas modules less than 30 seconds and only a few hundred KB. And the module just takes up 70 MB in memory and it can start in 4 seconds. For large application, we divide the business layer into many modules based on functionality. Developers can manage their own module independently. And the granularity of development and operation is much smaller, thus solving the collaboration issues. For example, we had a huge application in Ant Group. It's too large, so every time we had to spend 10 minutes to deploy it, and over 30 developers were working on it, leading to collaboration conflicts and slow iterations. It took 2 weeks to release a new version. Then we split it into 20 modules. The deployment time drops to 30 seconds, and the module developers can manage their modules parallelly, allowing modules to release 3 times a week. It means that the entire application can release 30 times a week, boosting our innovation and development efficiency. For many low-traffic applications, each application can be treated as a module, and you can deploy many modules on one base, reducing the resource cost. For example, let's talk about the Nanjing F6 company. They had a lot of long-tail applications. Each application requires at least 2 machines per data center. Their CPU utilization is about 10%. So they employed couplers to deploy 6 traditional applications onto one base. This move significantly reduces their resource cost. And it also makes their application start much faster, from 100 seconds to 20. Literally, we provide a suite of tools to help you to split a large application into modules or transform application into modules, allowing quick adjustment to meet the business needs at a different time. It's very flexible. And our module can run as an independent process or as a module with other modules deployed on one base. Then let's talk about our secret tools, the core capabilities of couplers: modules, sharing, isolation, and our new serving platform. So how to produce a module, how to design the isolation and the sharing between them. We know module is a standard Spring Boot application without the common business logic nor middleware. So we just needed to set the common dependencies as provided. And the module is built as a jet package rather than the Docker image. So it can be built much faster and support hard deployment, which means that no server restarting is needed when deploying the module. and to ensure the and object isolation. And we also use a class delegation and provide cross-module object finder for class and object sharing. Then let's talk about our serving platform. In Catalyst, our base runs in a pod and our module runs in a base. So we should design a module scheduling to allocate modules to their bases, thus creating a two-tier serving platform. Usually, we will construct a new module controller, but it's high cost and also hard to adapt for different companies because they always build their own serving platform. So how to solve it? We use virtual kubelet to map our base as a virtual node and our module as a virtual pod. So we can use Kubernetes deployment, scheduler, and controller manager for module serving. This approach leverages the existing Kubernetes framework, so we don't need to build any extra infrastructure. It's much easier to understand and adapt for other companies. For example, when storing modules in virtual Kubernetes, we just create a module deployment through the Kubernetes controller. And then the Kubernetes scheduler will assign the virtual pod to a virtual node. When our virtual Kubernetes finding a virtual pod is assigned to its virtual node, and syncs the virtual pod, virtual node, and the pod states. We can also use Kubernetes service to isolate modules traffic. So far, Kubernetes has been published at N-Group for 5 years. Since the open source of SurfArk in 2018, the following year, we set our modular research and development framework based on SurfArk, which is Surface Serverless. And after several years of refinement, Surface Serverless 1.0 was released last year, and they have already taken 400,000 calls in N-Group. And they also have received much recognition and praise from many internal developers. So we decided to open source it. And as for now, it has reached 700,000 calls in N-Group. And in the community, more than 20 companies is using it. In summary, Catalyst aims for 4 goals: speed as you need, pay as you need, deploy as you need, and evolve as you need. For speed, you can develop fast, start fast, and release fast. And developers can only focus on your business, and everything can run parallelly to achieve higher efficiency. For pay, our module don't cut any extra machine, so you don't need to pay for it, and it only uses a small amount of CPU and memory in the base. And we also design modular static scheduling to achieve higher resource. Our module can run as an independent process or as a module with other modules based deployed on one base, so you can adjust your deployment strategy flexibly to meet your business needs. And also the flexibility also extends to your changes, which is only limited to your module and its corresponding machines. For evolution, you can split the existing application into modules or transform it as modules. These modules can then evolve into microservices or revert back to monoliths. So how about the future? This is our original intention and also our goal. Let traditional applications evolve to a serverless mode at a low cost. We want the evolution to be affordable and feasible for legacy applications, not only for the new one. And it also sets Catalyst apart from other service platforms. So far, we have open sourced the initial versions of Catalyst runtime framework, development tools, architecture, and the serving platform. And we have served more than 20 companies. recently we will release multiplication data frameworks, and in Q3 we release a new version of serving platform. And further ahead, we hope we can collaborate with community to exploring the modularization together. We value sharing, communication, collaboration. If you are interested in Kubernetes, please feel free to scan the QR code to join our discussion group. You can connect us with Discord or GitHub or WeChat or LinkedIn. And do you want to experience 20-second modular deployment? Welcome to our booth and give it a try. Thank you. That concludes my presentation.
An increase in service mesh with a solution also by this company, Washbridge.
Okay, thank you everyone. I know now it's too late, so my speech will not be very long. And my name is Jerry. I'm from DAOcloud, and now my role is solution architect, and also I am responsible for our company's strategic business development. My topic is building an efficient service mesh. My presentation will include 4 parts. The first one is introduction and the technical background, and the second one is implementation and the challenge of ambient mesh. Third one is optimizing ambient with eBPF and Murbridge. And the last one is issues, performance, and also community resources. So first, give me 2 minutes to introduce our company and our team. DAOcloud may be not as famous as Ant Group, ByteDance. They are a very large company. DAOcloud is a small company, but we are innovative leader in cloud native and also application modernization area. So our company is founded at end of 2014. For the past 10 years, we continue to contribute to the open source community. So as you can see on the right part of this slide, there are many famous open source projects. Most of these projects are about microservices like EC2, like Prometheus, like other famous open source projects. And a small number on the right corner of each icon is the global ranking of our company. So now we ranked number 3 in Kubernetes and ranked number 2 in Istio in the past year. So now we have 2 CNCF ambassadors and 1 Kubernetes steering committees and also 1 Istio steering committees. So first I will introduce Istio. It's a CNCF graduated project. So it's a popular project used in many service mesh projects to control the traffics between services. So developers can easily control the traffic. They don't need to hard code the rules in the code. So this project was funded by Google, IBM, and lived in 2016. And now it's it have more than 36,000 and also more than 34,000 commits. And now in Dow Cloud, we have 3 maintainers and also we have 43 members of this project. And Dow Cloud contribute many to this project. So now we have 1 Istio steering committee in this project and ranked number 2. And we contribute to like new modes and new architectures to support supporting many new modes of Istio. And also we developed many features like analyze, check, inject, and also waypoint commands, and fix over 100 issues in Istio control. So what is Istio? As I mentioned before, it's an open source service mesh project. So it uses sidecars to control the traffic from service A to service B. We have proxies to redirect the traffics between them. So it secure by default, increase observability, and also it can manage traffic. So then I will introduce Mobridge. Mobridge now it is a CNCF and also a landscape project in eBPF. So why we create this new project? We have Istio now, but Istio use IP tables to control the traffic. It has many limits to use in the enterprise cases. So we create Mobridge to use eBPF instead of IP tables to improve the traffics and also accelerating the speed. As we can see, the speed can be increased nearly 10%. So this is a repo URL, and now we have more than 700 stars and 400 commits, and also 25 contributors. Nearly 2 years ago, and now Kuma and ASM to accelerate the speeds in their service mesh network. So what the Mobridge do is to use eBPF to replace the IP tables, and also we simplify the traffics between the services, between the ports. As you can see, I use 2 red circles to show this. As you can see, we simplify the traffics. Before Mobridge, the traffics from port 1 to port 2 is a very long journey. and after it's simple. And if the two ports are located in one node, the traffic will be the route will be simple. So when to use Burbridge? If you need high performance connections, where IP tables increase. Because many they may conflict each other. The third thing is maybe you have security concerns to limit the permission. You have limited permissions for some ports, so you can use Murbridge. You can try Murbridge. So then the part 2 is the implementation and the challenges of ambient mesh. What is ambient mesh? Ambient mesh is a new data plane proxy mode because it used to use sidecars to control the traffic. A sidecar may have may increase the resource utilization. So this new mode named ambient is use the node proxy and also waypoint mode to reduce the resource usage and lower the difficulty of use compared to the previous sidecar mode. So this is the traffic between the two ports. You can see the ambient also use IP tables by default. So it use zTuner to control to proxy the traffics between the two services. Or also use policy routing. So this may causing issues. So ambient mode isn't compatible with all CNIs. To address this, maybe you can use eBPF to solve these problems. But if you use eBPF to if you want to use eBPF to solve this problem, it can be done in some scenarios, but not all scenarios. So as we researched, there are some problems with ambient eBPF mode to control the traffics between two ports. However, it relies on the CNIs with peer network interface. So many other there are some CNIs have no peer network interface like MAC-VLANs. So ambient mode eBPF mode cannot be used in this scenarios. So we tried to use Murbridge to enhance the ambient mode. So we many other CNIs. So how to handle the traffic forwarding by default ambient mode? It's by matching whether the source IP of the traffic is ambient mode on the host. It is determined whether to forward the traffic to zTuner. But the eBPF program of Murbridge will directly determine whether the traffic needs to be forwarded to zTuner when the process is in the port initialized initiates the request. So I will not because of the time. So we solved some problems, but not all the problems. So there still have many known issues in this in Murbridge. So the first one is original source. The second one is message redirect. The last page is about the performance. As I mentioned before, we use eBPF to accelerate the network, and also we can adapt to many other CNIs. So this is we do a stress test to compare the Murbridge with the IP tables both. So we have nearly 5% to 10% performance improvements. It's not a very big improvement, but we are working on this to maybe we can achieve more. So these are the community resources. If you are interested with what we do, what we are doing, and also if you want to use our project, or if you want to contribute to our project, so you can scan the QR code. The left one is the Murbridge's repo. The right one is Slack. You can join our Slack channel to talk to us. If you have any questions, if you want to have a try, or if you have more requirements, need us to know. Then, if you're interested in our company, you can scan the code to QR code to follow our LinkedIn page. Also, you can visit our official website. We have many open source projects showing on our official website. So that's all.
Any question for all the speakers? They are still here from the beginning until now. Any questions?
Basically, I am using OpenShift a lot, and it still has an operator that we can use OpenShift.
It still
It still has an operator, but does Murbridge also have an operator?
Operator, yes, also. Sorry, Murbridge is not have operator. We are simple application demonstrate. So you can run just use one command. It is very simple. So, yeah. Thank you.
Anyone else?
I want to clarify that because I am not the developer of this project, so maybe I cannot answer every question, but I can write down the questions.
Okay, very good. Thank you, Cherry. Yes, so we still have a few present here. I think we don't have any questions now. Maybe a speaker should ask a question.
Yeah, thanks for the presentation. Thanks for everyone who was here in this room. And I found that previously we have some questions not being answered yet. So if you're still interested, you can hear, well, we can see it. Okay, please hand the microphone to this man, to this sir. Yes.
Apologies, this is a variant of my earlier question, but I was wondering if any of the presentations we had today, any of the solutions actually have a modular secrets and injected into the mesh. And in the other solutions as well, do they have maybe a modular secrets management solution?
Okay. May I ask your background? Are you from HashiCorp or?
No, I'm a DevOps engineer. I'm from Accenture, Accenture Consulting.
Oh.
So we're always looking for alternatives to
Okay.
HashiCorp Vault.
Okay.
Due to the costs,
Because of the license problem, right?
among other things, licensing. And for example, some areas like Hong Kong, the companies we work with, they cannot use HashiCorp Vault without a local
Policy.
or local vendor. And there is no local vendor in Hong Kong that directly represents HashiCorp. So we struggle to find people to support HashiCorp Vault, so we look for alternatives.
I think you are mentioning very interesting points. Actually, we have discussed this with the CNCF's CTO before. He asked for us the same question like you did today. Indeed, it's very important issue in this, especially in the cloud native ecosystem. We might want to find a new solution. Unfortunately, right now, in my dynamics, we all the management system. It's not open source yet, but we might be able to figure out a new way, maybe in the future. And right now, not right now. I think that that's not yet. It's not open source yet. But I will remember catch up your question. Thank you.
Just to note at the last point, this is a problem we find throughout Greater China for customers we have in Greater China, not just Hong Kong as well. It's a problem we're finding with our customers there. We don't really have a vaulting solution.
Okay. Thank you. Thank you. Do anyone have any questions related to RPC scenarios? Because we also have the another maintainer of KaiNext project, Yari, is also here. She can also answer some of the questions if you want to ask. The RPC scenario, especially in my Matthew production. Okay.
So I was talking about the so I was quite interested in the KaiNext itself.
Okay.
So particularly the aspect zero copy. So so the thing is that so if I remember correctly, the way it does it, this is basically allocate or basically index directly into the request or response. It means the index steals directly from the memory block allocated to the request or the response. So generally that works very well. But I'm just curious about how do you do it, particularly on the application side, wondering how do you deal with a variable with fields like strings, for example, where you how do you allocate a block and still account for strings that can have variable length?
Okay. I think you are
organization of this event. As mentioned earlier, we also run event in other city around Asia. The next one will be in Bangkok. So you can join the chat group in order to check out more events from us. Thank you very much, and I wish you have a good evening. If somebody still wants to try out the 20-second deployment, it's over there.
You ask the first one.